Should I start now?
Yes. Okay.
Yes, I can hear you. Yeah.
Okay.
Can you hear me?
Okay. Yes. Yeah. Yeah. Then please. Yeah. Please. Yeah. This here is yes, there is a presenter, so I can see there as a presenter. Yes. So yeah. Today is Fabian is a little developer of the Ethereum. Is going to present about the Escrow presentation. This Escrow is decentralized. Maybe the really functional and really useful application. It's already on the GitHub, but we can see more detail on it. Also, in the London DevCon, the presentation is with Alex-san and Christian-san is doing presentation about how to make the decentralized application. Then
Okay, Tomaki, should I start?
Yes. Yeah, you can start from now. Yes.
Okay, could you turn the screen so I can see the audience as well?
Okay.
Your computer? Yeah.
See the audience. Yeah.
So I see who I'm talking to. Okay, hello, good evening.
Hi.
Good evening.
Good evening.
Okay, so I will start with a short presentation about Ethereum and what Ethereum is, and after that I will showcase the Mist browser and also some dapps. So, second. Can everybody see the screen there?
Yes.
Yes.
Okay, good. Because I cannot see the video anymore. Okay, Ethereum, yeah. So I'm Fabian Vogelsteller. I'm the dapp developer for Ethereum. I'm building the Mist browser and I'm building the dapps, so the ones which come directly from Ethereum. So what is Ethereum? Just a short, quick overview here. So normally in the past we have a centralized solution for everything. So we have had a monarchy, even our current democracy is kind of centralized. So the problem of centralization is if you kill the head, the whole system fails. Therefore, things moving to decentralized systems. Decentralized systems means if you kill one node, the whole system still survives. It's resilient. In the Ethereum or in a blockchain technology, blockchain technology works that you have a specific set of records, like the blockchain, which is distributed over all peers, and because it's distributed everywhere and verified on each end, you cannot manipulate it or cannot cheat it. So this mainly works on the basis of blocks. A block contains a list of transactions. These transactions are put in a block, and this can be, for example, transfer of value, like from person A to B, and so on and so on. And these are put in the blocks, and they're secured by a miner. So the miner is mining those blocks, verifying that everything is correct, and all the other nodes validated as well. This makes it immutable. This makes it like not cheatable. And this is basically the main advantage of the blockchain, that you have a set of records which nobody can manipulate. And And the other key part of the blockchain is that you have identities. So each person has an identity which everybody can verify because they know that only the person who owns the identity has the password, has the key to the identity. So basically the private key and your public key, your identity, is tightly connected, and everybody can prove that when you sign something, for example, when you sign a message or any kind of transaction, they can prove it came from you. And nobody else can send those transactions, except the ones who has this key. And also, in the blockchain, everything is peer-to-peer. This goes directly from one person to the other and is verified by the others. So this solves the problem of trust. In the real world, we need to trust people, so they can give us a promise, but they also can break the promise. In the blockchain world, we basically trust the code. So the code does what it says it does, and we can all verify that the code does what it does because it is open source, and it is audited by many people. Ethereum is not it's comparable to Bitcoin because it uses the same underlying technology, but it is way more than Bitcoin. In Ethereum, we can not only move money from A to B, but we can have complete code which executes on the blockchain. Means I can have code which is executed in a series, and I can make changes to the state of the contract, and everybody can verify that those changes were made and what those changes are. So I can have a contract where nobody can cheat and everybody can verify it. So and writing contracts or writing code on the blockchain basically allows me to do anything. Ether, which is the cryptocurrency of the Ethereum network, it is comparable to the Bitcoin token. This is used as the fuel, means it is used to run computations on the Ethereum network, running computations in the Ethereum code. So every smart contract runs code, and this code needs the specific amount of fuel. The more code you have in your smart contract, the more complex your smart contract is, the more ether you will need to run it. And this allows that simple smart contracts need less ether and more complex ones need more ether. And the whole point of this is that it protects Ethereum from spamming, from overusing the Ethereum world computer. And this is actually what it is. The Ethereum network is like a world computer. It's not super fast, but it solves the problem of trust. And to see how a dapp, decentralized application, actually interfaces with the blockchain is, in this example, we see blocks like 1, 2, 3, 4, 5 to 8. So these are the blocks who are like mined one after the other. And we see the block 1, 2, 3 that just contain transfer of value. So money goes from person A to person B. In the block 4, for example, some kind of application makes a transaction which contains code. And because it contains code and it goes to nobody, he creates a contract out of it. And in the next blocks, he can make a transaction and modify the code. So he, not modify the code, but modify the state. So the code has a specific state, for example, who is the owner, or who is person A or B in the contract. And the application can later modify the state. It could change the owner, it could change to whom money goes, it could change whatever the code says. And then at any point in time, in block 8, example, basically at any point in time, the application can read from the state. So basically can check what is the current truth, what is the current state. And this is basically all there is. So this is how it interoperates. You deploy a contract, you modify the state, and you read from it. So reading is free, because reading is basically reading from your local node what is the current state. If you modify the state, you're actually executing code on the Ethereum blockchain, and therefore this will cost you gas. So this will cost you the ether, because you actually make corrections on the network, which node has to execute. So you basically can build almost anything. You can build certainly a lot. And you definitely can build things we couldn't build today. So it has a lot of potential. And for example, a few examples. Let's first talk about the Mist browser. The Mist browser basically is a web browser which allows you to browse the Ethereum network and browse decentralized applications, because it has an Ethereum node built in right away. So it will probably not replace your normal browser, and this is not the point. The point is that it allows you to access decentralized secure applications, move your money, transfer your money, or work in a prediction market, or have a company trust, or whatever, everything which has to do with trust. Because in the browser, you know, you are in control, and it has all these tools which make it decentralized. In the future, we can probably even have like modules like Ethereum-like clients in normal browsers, but for now, it is a standard browser. And examples for this is Locket. This is a startup built on Ethereum, and what they do is they do smart locks. So this means you can have a lock, and the lock itself can get paid, and the lock itself then opens and closes for whoever person paid it until money, the deposit is used, and then it transfers the money to the owner of the lock. So basically, it really allows you to do all these cool Internet of Things things which are coming. And Ethereum basically is the backbone of all of this, or can be the backbone. Other examples are contract editing tools, and these are already things which are existing. So this, for example, the Ethereum wallet. Argo is a prediction market. EtherX is a decentralized exchange. Provenance want to track process lines, so where my products are coming from. For example, if I want to buy some organic foods from Africa, I can be sure that it actually came from this organic farmer in country X. Or for example, even poker games, which are provably fake. And there are actually many, this is just a very small set of possibilities, but there are actually a lot of possibilities. Okay, I will now show you the Mist browser. So currently the Mist browser is starting up, and it's not looking for peers and will sync to the current height of the block. So currently the Mist browser contains a full node, so this will take a little bit. Actually, yeah. Okay, now I found peers, now we'll sync up to the latest state. In the future, it will contain a light client, and the light client will sync way faster than this. So once sync. Okay, so the Mist browser currently is an alpha version, so it's very early preview. It's not really public release. But you can already use it, and dapp developers are encouraged to try it out and develop the dapps in the Mist browser itself. For example, right now here we have loaded the wallet, the official wallet. And I can have contracts, a wallet contract which allow me to do multi-signature, so to have signature contracts. For example, this wallet with 1 Ether is owned by 2 people. And if I want to send money out of this contract, 2 people have to agree that we can move the money. And a few transactions already happened to this contract and from this contract, as you can see. You can see how much Ether was, for example, used for this transaction. That's actually way too much. Yeah, that's more realistic. So it's not that much. Actually, the gas you're using is not that much. It's more like in the 0.7 ether cents. This was a very high gas price. I don't know why. Somebody paid very much. And I can have my accounts. So my accounts, which you also can see up here, my accounts are basically my identities. So I can create an unlimited amount of accounts. Accounts is what you saw before, this public and private key. It's your identity. And I can hide and I can show accounts to specific dapps. For example, the wallet sees all my accounts, but I could also show only one or none. So the dapp doesn't know who I am. And if I allow all accounts, I can see all these accounts here. And with these accounts, they control these wallets, because the wallets itself are contracts, they're smart contracts. And as I said, it can be a multi-signature, where I can say it has owner ABC, it has 5 owners and only 3 need to sign a transaction, and everybody can send up to 100 a day. And we can basically build any kind of wallet you can imagine. The wallet currently also allows you to work with any kind of contracts. For example, if I want to just play around with any kind of contract and want to have a simple interface, I can add the contract here, and just give it the address and the JSON interface. And then I can interact with the contract. I can read its state, so it's logged, whatever the state means. And I can execute functions. For example, I can set the owner, and set the owner to a different person here. And then I would execute the transaction. But to simply show this Escrow dapp, which you wanted to see, okay, so the Escrow dapp, this is a very simplistic application, and it works kind of the same way like Slockit. Slockit was the smart lock, right? Where you pay the lock. In this case, you would pay the button. So the button has a smart contract, and the button reads from the smart contract who is the one who bought, who's the buyer, and who's the seller. And therefore it can present itself the right. So we have to now deploy a contract for this button. So we do this going to the contract and we deploy a new contract. And the contract is this one. So this is the whole contract. So this is a very simplistic version right now because you have one contract per purchase. Normally you would have like one contract which can have multiple purchases, but then it would be a more complicated contract. But itself, basically it has the key confirmed purchase, who basically says who's the buyer, what is the current state, and then you can confirm that you received it, you can refund, and so on. It's not that long, it's 100 lines of code. Okay, so we now put the code here and we will deploy the contract. Purchase contract, and we have to give it the amount of ether. Actually, we have to switch to another network. Okay. Okay, let's do it on the main network. I think this will take way too long otherwise. do it in the main network. Because the test net, I didn't use the test net, take too long. So do it on the main. So we'll take the contract, put it in here. We basically say we want to put 2 ether. 2 ether means the product will cost 1 ether, and I have to put an extra deposit of 1 ether. So we now do this contract, and Mist always, when you make a transaction, Mist will ask you, show you confirmation, so you basically see what you're doing, and nobody actually can just, like no dapp can make transactions on behalf without you confirming it. So we're basically sending from this address to this address to no address. So we create a contract and we send this to code we send to the Ethereum blockchain, and we send 2 ether with it. So this now needs to be mined, and this depends on how fast the network is, which is, it will be around 10 to 15 seconds, if we are lucky. It can also be longer. Okay, but we can see here what we actually did. So this is the current transaction hash. We sent 2 ether from this account, and it cost us 121,000 gas. Oh, this is the one we provided. This looks a little bit too low. No, this looks a little bit too low. Okay, good, it worked anyway. Good, so it cost in total 300,000 gas. So this is the actual gas which was used. And it cost us 0.1. Okay, this is not okay, this was a crash. Okay, but the contract was added here. So this is the purchase contract. So we see this is the seller. The price of the item is 1 ether, and this is represented in Wei. Wei is the smallest unit in the Ethereum network, which is 19 decimal points after the 1, and it currently has no buyer, and the state is 0, so it means it's not, nothing is defined, so it's like free to buy. So what we have to do is basically copy this code now. We go on our escrow, and we basically here have our buy button. And we're basically just copying the code, the contract code. So now the buy button knows which contract to use. And if we save this and we go to our escrow server. Okay, if I'm setting this is the person who sold it. If we allow this dapp to see this account, and this is the thing with live presentations. Okay, there's something wrong with my connection. I think this is because of this crash. Okay. And that seems to be not responsive right now. Okay, very strange. So I assume that another piece no. What does it mean? Okay, now it works. Okay, so we set this to the buyer, and the buyer reads from the contract that this person here, this count, this 0x account 5, is basically the seller, and therefore the seller, now I have the possibility to cancel the sale. So I could cancel the sale. If I would cancel the sale, it would look like I would basically make a transaction to the contract, telling him to execute this function. So this is the ADI of the function, and this is